All right, today we are going to be looking at going the opposite way. This time I am going to give you a graph and you are going to give me the equation instead of me giving you the equation and you giving me the graph. So we're going to look at our first graph right here. And I want to find an equation for this. And I'm going to do this in the simplest way that I possibly can. So all of the ones I'm going to give you today are either going to be sine or cosine curves, and then we will go from there, okay? So in this particular one, because the graph starts up here at its high point, you know that it's a cosine curve. So that much I can see. I know that it's a cosine curve. I know that it is not flipped because cosine normally does start at its high point, so I do not need a negative in front of that equation. This right here is the midline, and the midline in this case happens to be at 0, so the midline will be at the end, so I will have a plus 0 right there. The amplitude is your difference between your midline and your high or low point. So my amplitude in this case will be 3, and the 3 will go out here. Again, it does not need to be negative because it's not flipped. And then right here, you need a number that goes in front of your x, and this is your w. And your w will be 2 pi over your period. Your period is also 2 pi over your w, and your w is 2 pi over your period. They go hand in hand. Lots of people look at this graph and say the period is 5 pi because that's where the graph ends. Common mistake. But your period is where your cycle starts to repeat itself. So if you think it starts high and goes down and returns to its high point right here at 4 pi. So its period is actually 4 pi. So the w will be 2 pi over 4 pi, which of course reduces to 1/2. And then this is the number that goes in front of your x right here. And this is all that I need to do to find the equation for this graph. Okay? On to the next one. In this one, you can see that the graph begins at the origin or at the midline. And because it begins at the midline, you know that it's a sine equation. So I know, again, that I'm going to have a sine equation. Typically, sine starts and it goes up right here. This one doesn't. It goes down. And so because it goes down, I do need a negative in front of here. My midline is right here. And if you look at the scale on your y-axis, you can see that your midline is 0. So I will have a plus 0 back here. Again, the amplitude is the difference between your midline and your high or low point. In this case, that's 2. So that's what's going to go right here. And you need a number, a w in front of the x. And again, your w is 2 pi over your period. In this case, my graph starts here, goes down, comes back up, goes down, and is going to be pi. So I will have 2 pi over pi, which is 2. Okay? And that will be the equation for this one. Moving on to the next one. This, you can see, starts at its low point, and that means that it is a cosine curve that has been flipped. So I know I need negative, I know I need cosine. Again, it's at its midline. The midline is 0. You're going to get a packet pretty soon where the midlines are not all 0, so I just want to point all of these out. The amplitude, again, is the difference between the midline and the high point or low point. In this case, it's 4. And then I get my w by doing 2 pi over my period, which in this case is 2 pi over, your cycle starts to repeat itself right here. So 2 pi over 4, which will be pi over 2. And that is the equation for this graph. Okay, now we're going to look at one real life situation right here. It talks about a buoy that's bobbing up and down in a lake channel with the waves. It moves a total of 6 feet from its high point to its low point. It never dips below water. And it returns to its high point every, and this is being cut off on my smartboard, I'm sorry, every 10 seconds. Assume that at t equals 0, and that's time, the buoy is at its high point, okay? So there's some key things in here. It moves a total of 6 feet from its high point to its low point. It never never goes below water. And when the time is 0, it's at its high point. So I like to go down here and kind of just sketch a little bit about what's happening. Your x-axis will be time, and your y-axis will be height of the buoy in this case. So it's saying when the time is 0, it is at its high point. So if I kind of sketch this, when the time is 0, it's at its high point. Already I know that this is going to be a cosine curve. Not flipped, but it's at its high point. Okay? It moves a total of 6 feet from its high point to its low point. So this distance between here and here has to be 6 feet. And it also says that it never dips below water. Okay, so I'm going to consider water to be a height of 0. And it moves a total of 6 feet then, so this is going to be 6 feet high. So then you can figure out your midline by going halfway between 6 and 0. Well, halfway between 6 and 0 is 3. So if I go back up here and I figure out my midline is my high point plus my low point divided by 2, and that will give me 3. Your amplitude is your high point minus your low point divided by 2. So in this case, 6 minus 0 divided by 2 is also 3. And that's not always the case. It doesn't always work, but in this case it did. Again, I'm going to tell you that you get your midline by doing high point plus low point divided by 2. Okay? You can see the amplitude right here. So the amplitude is 3. The midline we already know is 3. I'm going to label this point as 3 right here. Okay? The amplitude, the difference between 3 and 6 is 3, and that will give you your amplitude. So that we're working out just swell so far. What else does it tell us? It tells us that it moves, it returns to its high point every 10 seconds. When it talks about how much it returns to its high point, this distance right here, that will be your period. And so your period is 10 seconds. And so what I will do is I will go over here, and this right here is 10 seconds. And then half of that is 5 seconds. Obviously, if we talk about time, we usually measure in decimals, so I'm going to give this in decimals. 2.5 seconds, 5 seconds, 7.5 seconds. Okay? And so your curve will look something like this. It starts at its high point, it goes to the midline, down, up, and returns to its high point after 10 seconds. Your curve will look like that. Okay? So that period that we just talked about, returning to its high point every 10 seconds, that's what that gives me. Notice my x-axis is labeled with my period, not my w. Okay, I get my w then by doing 2 pi over 10, which is pi over 5. Okay, then when I want to make my equation, I sort of put all those parts together here. So I know this is a cosine curve. I know that it's not flipped, so I do not need the negative. But my amplitude is 3. Cosine, my w was pi over 5. And then my midline in this case was also 3. When you do your packet, you are not going to have to calculate any phase shifts, any left-right shifts, unless I give it to you in the equation. So I could have had you made you figure this out as a sine curve that has been shifted and then figure out how much it shifted. But it is easier to call this a cosine curve, and so that's what we are going to do when we do our homework, unless I tell you otherwise. There will be times when I tell you otherwise, but for now, label it as either a sine or a cosine curve, whichever is easier, and you do not need to figure out the shift. Okay? Then the last question, what is the height of the buoy after 2 seconds? If you think about your graph, your height is along your y-axis, so I am asking you to figure out what the height is after 2 seconds. Time is on your x-axis. And so what you're going to do is you're just going to plug in 2 seconds into the equation that you just calculated. So I will use this equation, the one from up above. I'm just recopying it here. Again, time is along your x-axis, so you're going to put that 2 seconds in for your x, and then you're going to just simply put your calculator into radian mode, and because you have the pi over 5 is in radians, and so you have to have your calculator in radian mode, and then you are going to just simply put that into your calculator. And I don't have an answer, so I have to do it right along with you here. Let's see. I'm using my calculator that I have. I'm not going to pull up my screen one because it'll take too long, but you're going to put in cosine at pi over 5 times 2, and then add 3 to that. And you should get about 3.93 feet. Okay, and let's look at the graph and kind of see if that makes sense. At 2 seconds, so here's where 2 seconds is about, and if you look up, 2 seconds is probably about 3.93 feet. That looks like it would work on the graph. Okay, so there you go. That should do it for today.